Assalamualaikum and good morning. We are Group 10 from Section 1 Probability, Statistical and Data Analysis. We will be presenting our finding of statistical and inferential data analysis on student academic performance. First, the objective of our study is to explore how different demographic and background factors may be associated with student accomplishments. So to do this, we are using four kinds of testing. So the first one is the two-sample testing. The two-sample testing is to compare the average mid scores between genders. Next, the correlation analysis to explore relationships between med scores and the final result. After that, we are using regression analysis to see if higher attendance rates predicts higher med scores. And lastly, chi-square test of independence to see if the test results are associated with parent education background. So our end product for this project is to seek valid and statistically supported conclusions from the data that we obtained. So this is the data set. So the data set that we use is the student academic performance. So we are using the clean version that has 681 students. The data set we obtained from the Kaggle. So this data set has a few variables that we use, such as the grade level, the math score, the parent education, the final result, and other variables that we use in these four different kind of tests. So the tools that we use are RStudio. So the reason why we're using RStudio is because it is robust and able to handle large set of data. So we are also using the bar graph and the box plot for an example to interpret the data more easier. That's all.
And hello, my name is Muhammad Akib Zain. So I'll be doing hypothesis testing for the average test score map for gender. As you can see here, there is no difference in mean math scores between females and males. This will be our null hypothesis, which is the mean population of female is equal to the mean population of male. So the alternative hypothesis will be the mean population of female is not equal to the mean population of male. So since the population variances are unknown, we are using the t-test to calculate the test statistic. So with the confidence level is 95%, so is equal to 0.05. So all the calculations such as sample mean for both gender, the standard deviation, and also the t-test, we are using the R programming. So this is the implementation of the R programming. So as you can see here, if we read the data based on the Excel sheet, and this is where I separate the data by gender. This we have female data and male data. As for here, I want to extract the math score. So we have female math and also male math. So in this part, I want to display the summary statistic, which is we have total size, which is the length of female and also the length of male. It will be the length female like will be the 335 and male data will be 356. So this is where the mean, you will print the mean of the math score, also the standard deviation, and this is where the t-test will be performed. So wait, I will wait. Okay. So as you can see here, we get the length of the female will be the 325. As for the male, we got the 356. And for the both gender, this is the mean math score of the both gender. So for the female, we get 75.076992. As for the male, 74.27809. This is the standard deviation. So this is where we obtain the t-value, degree of freedom, and also the p-value. So as you can see here, our t-value is 0.74, and for the degree of freedom is 676.68, and for the p-value is 0.459. So as for the visualization, so as you can see here, the p-value is equal to 0.4, which is we have exceeds our significant threshold, which is the alpha is equal to 0.05. So we have exceed the significant threshold. So as for the t-value, it falls within the acceptance region, which is the result will be we fail to reject null hypothesis. So the conclusion is there is no significant difference between both gender in average test score math. So that's all from me. Thank you.
Now I will talk about the chi-square test of independence. So the reason I chose chi-square test of independence instead of the ANOVA and also the good of fitness test is because I want to test whether there is significant association between two variables, which is the final result and also the parent education. So the null hypothesis will be the final result is independent to the parent education, and the H1 hypothesis will be the final result is dependent to the parent education. So to test whether we reject or fail to reject the null hypothesis, we have to do the chi-square test of dependency. So the first thing first, we have to create the contingency table by doing the table function and input the final result variable and also the parent education variable. After that, I store the contingency table inside the table result and print out the table result. So as we can see here, this is the contingency table, which has 4 columns for the parent education, which is the bachelor's, the high school, masters, and also the PhD. And we also have 2 rows for each column that have fail and pass value here. So as you can see here, the bachelor's fail number count is 96, and the number of students that pass is 99 for their parents is a bachelor's holder. After that, we have to do the chi-square test by using the chi-square dot test function here and the table result as the parameter here, and store the chi-square result. And this is to check whether the chi-square test is valid or not. So if the expected count is less than 5, the chi-square may not be valid, but if it's more than 5, then the chi-square test is valid. And after that, we have to show the chi-square test, the expected result. So this is the chi-square test statistic result. So we get the x square value is at 1.6498, and the degree of freedom is 3 by to get the degree of freedom simply by number of rows minus 1 times number of columns minus 1. So we have 4 columns minus 1 times 2 rows minus 1, we get 3 here, and the p-value is 0.6481. And this is the output for the expected count. So based on the chi-square test of independence, the p-value obtained was 0.6481, which is significantly higher than 0.05 confidence level. So this indicates that we fail to reject the null hypothesis, meaning that there is no statistically significant relationship between a student's final result, which is pass or fail, and also their parents' education level in the given data set. So in simple terms, the data suggests that the students' success or failure does not appear to be influenced by their parents' education background. And additionally, I create a bar plot. So as we can see here, this is the bar plot for the final results by parent education. So we can see here the number of students that pass. So this is the fail number of students that fails that their parents is bachelors, and this is the pass. So this is basically another graph for the contingency table. So I think that's all for the chi-square test.
For the regression part, we have two variables for independent and dependent variable. Dependent variable will be y-axis and independent variable will be x-axis. So from the data set, I choose study hours for the x-axis and MET score for the y-axis. So the hypothesis, which is the more study hours you study, and then there will be the more MET score you get. But is it these two variables? We fulfill that hypothesis. So let's do our regression. Then we move, like I run one by one line. So we just import our data set, and then we set our x and y. And then there's a function for the regression. We have model. So LM actually means linear model. And then we call out that model. So we have here our intercept, which is 7.75.2617, and our slope, which is negative 0.2012. And then we move to next slide, which is we plot our graph. So study hours will be x-axis and MET score will be y-axis. So the range from 1 to 5 for study hours, and for the MET score will be 50 until 100. Then we move to mean to find our SST, SSR, and SSE. So mean for the x variable and y need to be calculated first. So we have mean x and mean y, and then we need to put our sample size, which is right now we have 681. So n equals to 681.
we sum x and y, and then we power of 2 for x, and sum x power of 2, sorry, and we calculate sum x multiplied with y. And right now, we have b1 equals to sum x multiplied with y minus sum x multiplied y over n divided by sum x power of 2 minus sum x power of 2 divided by n. So we have here b1 equals to this value, and then we print out we go to b naught b0. So min y minus b1, which is we calculate before this, multiplied by min x. So this is a value for b0, our intercept. And then we have here SSR, which is sum of y hat minus min y power of 2. So then we have our value of SSR. And then we move to SST. SST equals to sum y minus min y power of 2. So that's a value for SSR. Sorry, that's a value for SST. And lastly, we have SSE. So SSE equals to SST minus SSR, and that's a value for the SSE. And the last part, which is R coefficient R, SSR minus by SSR divided by SST. So our value is 0.002748885. And the another part, we need to calculate our T. So our K right now is 1, and SE equals to square root of SSE divided by divided by n minus K minus 1, and we calculate our SE and get that value. Also our SB1, and lastly our T, which is B1 minus 0 over SB1, and we get our value T negative 0.4320887. Okay, for the graph, we have study hours versus math score. We estimate students who have more study hours will get the higher math score or the else. But from this data set, it shows some students who have the more study hours but get the lower math score. And beside that, there are some students who have less study hours but still can get a higher score. So from this blue line, you can see there's no relationship. And from our hypothesis testing, there's a H null, which is B1 equals to 0. So it shows that no relationship, or and H1, B1 not equals to 0. So linear relationship does not exist. And sorry, does exist. So we calculate our T and we get negative 0.4320 with our significance level, significance value equals to 0.05. So our T critical is 2.326 on the right tail and negative 2.326 on the left tail. So from the we estimate the graph from the T graph. So we get our T value in the middle. So when in the middle, we fail to reject H null. So we accept H null. So it's tally with our graph.
Okay, so hi, my name is Muhammad Lafan, and I'll be talking about on correlation analysis. So why did I choose to do correlation analysis? So first of all, this analysis is aimed to determine whether there's a specific significant relationship math score and students find academic result. So correlation between math score and final result, the X is denoted as a math score and Y denoted as final result. Pass or fail, where N equals to 681. As you can see here from the data set, we have 681. We have 681 entries and students. Next. So the final result variable was coded to the numeric binary format, where pass equals to 1 and fail equals to 0. So by using Spearman's rule, it is this P correlation rule. We can find, and the R is estimated as a result of the correlations using RStudio. So after inputting all the data, you can see that the p-value is 0.2246. So the alternative hypothesis is true. So rho is not equal to 0. And the sample estimates that rho equals to 0.04659522. So with the formula of core, rank which is mass score and rank which is final result, and the mass experiment, the rho is which is the same as the formula that P equals to 1 minus 6 d square over n bracket n square minus 1. And that's how we get 0.04659522, which is 0.046667. Or di is the difference. So that we can, anything that we can plot the scatter graph and set a plot, which as you can see, scatter plot of the mass and final result has no correlation between it because it's binary. It's binary. So here where I show the calculation on how I find correlation without using RStudio. As you can see, the value is the same as RStudio, and here's the scatter plot, which I narrow down so we can see it clearly better. As you can see, there's no, the correlation coefficient here is 0.0466. So this shows that's a very weak positive correlation and it's not significant. So students with higher math scores are slightly more likely to pass, but the relationship is very weak, so there's no association between math score and the final result. Thank you.
As conclusion, the research team has learned there's need to consider what kind of analysis test beside of the objective of study, because we have two main priority, which is the objective of study and what kind of analysis test we need to do for our study. Other than that, we need to determine what type of data, which is nominal, ordinal, ratio, or interval. So by doing this processing data by doing this processing data, so our research team also need to stick with objective of study, or else we will face the problem during the analysis test. So from our data set, we can analyze what kind or what thing can be added and improved in educational to get the student full potential in academics. Moreover, we can determine what of the main factors that influence students' academic performance. Thank you from us.